Good morning, my students. I hope everybody is doing well. This morning, we have come back to continue our lessons, and I hope all of you are doing your exercises and at the same time copying your notes. Estrella, Judith, Teresa, Donna, Emma, Sergio, Carota, Estelle. I hope you people are doing wonderfully well. So this morning we are continuing our lessons. The subject that we are coming to do is science. The subject that we are coming to do is science. And then the topic is what? How to calculate mass and then weight on the moon. The mass on Earth and then weight on the moon. That's the calculation that we are coming to do today. But before that, we have to go back to what we learned the other day. We learned the differences between mass and then weight. And then we said that mass is the amount of matter in an object. Mass is the amount of matter in an object. The unit of mass is kilogram. The unit of mass is kilogram. The instrument for measuring mass is scale. The instrument for measuring mass is scale. Then weight is the amount of force that pulls objects towards the earth. Weight is the amount of force that pulls objects towards the earth. The unit of weight is Newton. The unit of weight is what? Newton. It was named after Sir Isaac Newton, an Englishman. The instrument for measuring weight is force meter. These are some of the things that we learned about mass and weight. Now, if we are to find the difference between mass and weight, you can say that mass is the amount of matter in an object, but weight is the amount of force that pulls objects towards the earth. You can also say that the unit of mass is kilograms, but the unit of weight is Newton. The instrument for measuring mass is scale, but the instrument for measuring weight is force meter. These are the difference between mass and weight. Now, let's go back to our topic today, mass and weight calculation. On Earth, a mass of 1 kilogram weighs about 10 Newton on the moon. A mass of 1 kilogram weighs about 10 Newton on the moon. Therefore, 1 kilogram of mass is equal to 10 Newton. So here, 1 kilogram times 10 is equal to what? 10 Newton. So on the moon, I've told you that object on Earth, when it is 1 kilogram, on the moon it is 10 Newton. If it is 5 kilogram, on the moon it will be multiplied by 10. So 5 times 10, it will be 50 Newton. If you have 100 kilogram, the mass of the earth, on the moon, the weight will be 1000 Newtons. So looking on the board, we have object mass, that's on the earth, and then we have weight on the moon. Mass, that's on the earth, and then weight on the moon. So we have 1 liter bottle the moon is what? 10 newtons. So here it is what? 10, 1 times 10 equals to what? 10. The same thing if you have 16 liters drum of water, 16 liters drum of water, the mass on the earth is what? 16 kilograms. On the moon, the weight is what? 160 newtons. And then it is what? 16 times 10, which will give you 160. The same thing if you have 5 kilograms of apple. So here is what? 5 kilograms on earth. Then on the moon, the weight will be what? 5 times 10, and it will give you 50 newtons. The same thing if you have 20 kilograms of what? Sugar. 20 kilograms of what? Sugar. It will go on the mass on the earth, it should go at 20 kilograms. And then on the moon, the weight will be 200 newtons. That's 20 times 10. It will give you 200 what? Newtons. So if you want to calculate this one, we are saying that 1 kilogram is equals to what? 10 newtons. On Earth, 1 kilogram is what? 10 newtons, the weight on the moon. So any number that they will give you in kilogram, that's the mass on the earth, you have to multiply that number by 10. And it will be the weight on the moon. It will be the weight on the moon. It will be the weight on the moon. So if you are giving, let's say 3 kilograms. This is the mass on the earth. So 3 kilograms, you are going to write 3 kilograms times 10. And then the answer will give you 30 newtons on the moon. That's the weight on the moon. The same thing. If you have, let's say, 5.5 kilograms, that's the mass on the earth. You are going to write 5.5 times what? 10. So 5 times 5. Here, since we have a point inside, then we have times 10. So the point will move to this place. So the answer will be what? 55 what? Newton. 55 Newton. The same thing if I have, let's say, 17.3 kilograms, the mass on the earth. On the moon, the weight will be 17.3 times what? 10. So here, this point will move 1, and it will be 173 Newton. So if you are given numbers that are having decimal point inside, this is how you do it. You move 1 on your right side. You move 1 on your right side, and then you get the answer. So if you are not giving the decimal numbers to, this is how you just multiply the number by 10, and then you get the answer. Children, I hope this calculation, that the mass on earth and then the weights on the moon, you have understood it. I've told you that here on the earth, a mass of 1 kilogram weighs what? About 10 newtons. So here we have 1 kilogram is equal to what? 10 newtons. So we have 1 kilogram times 10 is equal to what? 10 newtons on the moon. So what you do is, I've told you, if the number is given to you, multiply the number by 10 and you get the weight on the moon. If it is a decimal number, what you do is what? You just move the decimal point 1 on your right. Just move the decimal point 1 on your right and you get the answer. I hope you have understood everything that we have done today, how to calculate the mass of an object to the weight of an object on the moon. So when it is the mass on Earth, you calculate it, and in the moon, how it will be. That's what we have learned today. Thank you, and we will meet again next time. Bye.